Hello, today we're gonna learn about GUI programming using PyQt6. And this is the first part. So first we're gonna learn about what is PyQt and we're gonna learn how to create first app with PyQt6 and also learn about PyQt6 signals and slot. So what is PyQt? PyQt is a Python library for creating GUI applications using the Qt toolkit. PyQt is a GUI widget toolkit developed by Riverbank Computing, and the latest version of PyQt6 based on Q6, which was released in 2021, and the library continues to be updated. So why do we learn about PyQt6? So let's look at the advantages of PyQt6. First, is cross-platform compatibility. It can run on Windows, Mac OS, and Linux. And it also has comprehensive widget set, several pre-built-in widgets and control, so that we don't need to build widgets by ourselves. Uh, and it also has strong documentation and community support, and this is very useful and valuable when we encounter some problems or issues. And PyQt6 also allows us to uh, write the program in object-oriented programming paradigm. And with the signal and slot mechanism, it will help students understand easily more about event-driven programming, which is important in developing user interaction programs. And it also has modern look and feel. It adapts to the native look of different operating systems, and it's scalable. It can handle large complex applications, and it also integrates well with other Python libraries. And Qt is widely used in industry for developing professional applications. So first, if we want to use PyQt6, we need to install uh, PyQt6 library, and this can be done by executing command pip3 install PyQt6. And then now let's look at the widgets or the user interface components, uh, like buttons, labels, windows, dialogues, progress bar, and widgets are often nested. For example, a window can contain a button, which in turn contains a label. And this window shows sample common Qt widgets, which you can see that we have like label, radio box, buttons, table, and combo box, and slider, and progress bars. So now let's learn how to create the first app using PyQt6. Here you need to use Q application and Q widget from the library PyQt6.qt widgets. So we need to write from PyQt6.qt widgets, import Q application Q widget, and then we import sys, which means system, in order to access command line arguments. And first, we need to create the app by using Q application, and then with the parenthesis sys.argv. Argv here mean arguments, and here we want to create the window widget. So we say window equal to Q widget, and then we need to show that uh, widget. So we say window.show, and then we need to start the event loop to run the app. So we say app.sq. So after we doing this, then we get the window show up in on our computer. And these are window on different operating system. The left hand side is the window appears on Windows. The middle one appear on Mac, and the rightmost one is the one that appears on Linux. Okay, so here in the window.py, which I just explained, you can see that first we need to import PyQt classes. Here we import Q application, which is the application handler, Q widget, which is a basic empty GUI widget from Qt widgets module. And then we create instance of Q application with the command app equal to Q application sys.argv, and these are requirement of Qt. Every GUI app must have exactly one instance of Q application, and sys.argv is the command line arguments passed to the application. And to actually see something, we create a simple window widget, window equal to Q widget. And then we tell Qt to show the window on the screen with the call of the function show. And then the last step is to hand control over the Qt and ask it to run the application until the user close it. And this done via calling app.sq to start up the event loop. So what is the event loop? It's the core of every Qt application. Uh, so Q application class is the core of every Qt application. Every applications need one and only one Q application object to the function, and this object holds the event loop of the application, and the core loop will govern all user interaction with the GUI. So let's look at the picture here. So here you can see the event queue, right? And this is the interaction. And the event loop will handle the event, and so it will correct all the events that come from the user interaction and keep executing those events. So each interaction with the application, such as click of a mouse, generates an event which is placed on the event queue. And here on the left hand side is the event queue, right? And on the right hand side is the event loop. And in the event loop, the queue is checked on each iteration. And if a waiting event is found, the event and control is passed to the specific event handler for the event. The event handler deals with the event, then pass control back to the event loop to wait for more event. Human window is a pre-made widget which provide a lot of standard window features, including toolbars, menu, status bar. And if we want to create window, uh, if we use QMain window, it will be more specific than using Q widget, because Q widget is like a general widget, right? So yeah, we need to import this, and you import Q application and Q main window from PyQt6 Qt widgets. And then we need to create an app by using Q application. And here window, instead of equal to Q widget, now we're gonna say window equal to Q main window, and then window dot show. And observe that now you can see that we have the like icon, and the uh, icon where we can close the window, right? Compare with when we use Q widget, it's just like nothing here, right? I just so if we use Q main window, it will have like more specific functions for handling window. And if we want to create a custom window, the best approach is to create the subclass of QMain window, and then include the setup for window in the init block. And this allow the window behavior to be self-contained. We can add our own subclass of QMain window, call it main window, to keep things simple. Here we create subclass of QMain window with main window. And in the init method, we use the concept of object-oriented programming that we have learned previously by calling the init of the superclass, right? And the superclass here is the init of QMain window. The main window class inherits from the QMain window, and the super method return the parent object of the main window class and call its constructor. So here it will call the constructor of human window, right? And then the init method is a constructor method of uh, so here we reuse the init method of the superclass human window. Okay, here suppose that we want to have menu bar in the window. What can we do? So here we can set the window title by using the function set window title here, and then specify the string for the window title. And then next we get the object of menu bar by calling the menu bar function. And then uh, here we gonna on Mac you need to call the function set native menu bar false, otherwise we won't see the menu bar. But I'm not sure about on Windows. But if on Windows you don't see the menu bar, you may want to also have this line of code. And then next, we're gonna create the file menu by using the uh, function add menu file to the menu bar object. And then here in the file menu, we add action new and open save exit. So that's why we see the action new open save exit in the file menu. And then start the event loop by first create the app object by using Q application. And then here we create the object of the main window, right? Remember that the main window is the subclass of human window. And here in the main window in the init method, we actually create the menu bar that has the menu action of new open save exit. And then we print about to show window and then call the method window.show. And then after that, we call app.exit. Here we're gonna see the menu in the window. Okay, suppose that we want to have the push button in the window. Here then we can use the Q push button object. Press me here at line number 10. We create the button by using Q push button. And then if we want to place the button at the center of the window, then we say cell.set central widget button. And here we can have the push button at the center of the window. And okay, so for the code that we just look at, here we can see that in the init block method, um, there's the method set window title that we can change the title of the main window. And then we add the first widget Q push button to the middle of the window by calling the function set central widget. And we can also specify the size of the widget by calling the function set fixed size. And set fixed size here will accept the Q size object. And in the Q size object, we can specify the width and the height of the size of the widget that we want it to be. And in this example, we create a fixed size window of 400 multiply for 400 for the width and 300 for the height. Okay, now let's look at the PyQt6 signals and slot. So if we want GUI apps to do something when we create GUI application, we typically want them to do something. What we need is a way to connect the action of pressing the button to making something happen. In Qt, this is provided by signals and slots or events. So what are signals? Signals are emitted when a specific event occurs. So like if we click a button, then that's event, and then that signals are emitted or sent. And slot are functions that are called in response to a signal. And uh, signals can be emitted uh, to many slots, and one slot or function can handle many signals or many events. So signals are notifications emitted by widgets when something happens, like when we press a button, or when someone enter the text in the input box. And slot is the name of Qt used for the receiver of signals. And the example of slots are functions or method in the application, and it will be connected to signal. Okay, so let's see the example here. Suppose that in the Qput button that we add in the window, and when the user click at the button, we want the message click to be print on the console. Then at line 12, we add the code button.click.connect cell the button was clicked. Here, slot is the function, and that function is the button was clicked. So when the button is clicked, then the button was clicked function is executed, and then that's why we see the message click uh, on the console when we push the button or when we click the button. The check signal also provide a check or toggle state for the button. So for normal button, this always false. So our first slot ignore this data. However, we can make our button checkable and see the effect. Okay, so here we can see that now at line number 10, we call the method set checkable to be true, right? And then here we connect the signal button click to slot or to function. The first function is the button was clicked, and the second function is the button was toggle. So when the user click at the button was click is call, right? And the button was toggle is also call, and that's why we see the message check, and then the status check is true because uh, now uh, the check status is changed from false to true because we click at the button. And next we're gonna look at how we can uh, store the data. Often it is useful to store the current state of a widget in a Python variable, and this allows us to work with values like any other Python variables and without accessing the original widget. You can either store these values as individual variables or use a dictionary if you prefer. Okay, so here you can see that um, we have the check variable here, right? And line 10 to 12, here we uh, call the method set checkable to be true uh, because the default value is false. And then we also connect the click signal with two slot or two function. The button was clicked and the button was toggle. And at line 18 and 12, the button was toggle is that we pass the value of the variable check and print the value in this method. And here is another example of storing data code. So at line 12 here, we actually now connect with the slot on the method. The button was released. So here in the method, the button was released. Uh, is actually update the variable button is checked, and here at line number 8 button is checked is true, right? And then inside this release method, button is checked is updated with the value that returned from the function is checked. So if is check is true, button is checked is true. But if the function is checked is false, then the variable button is checked is false. And then we print the variable button is checked. So first button is checked is false, but then when the user release the button, then uh, check and release, then the value of button is checked is true. Next, we're gonna look at how we can change the interface. So far, we have seen how to accept signals and print output to the console. How about making something happen in the interface when we click the button? So let's update our slot method to modify the button, changing the text and disabling the button so it's no longer clickable. Okay, so yeah, let's look at this example. In this example, when we click at the push button, the button is not clickable, right? And the text is changed. And how can we do that? So observe that at line 12 or at line 11, button click connect signal is connect with the slot the button was clicked. And in the button was clicked, we can change the text of the button by calling the method set text. And now we change the text to be you already clicked me, right? And then we uh, call the set enable to be false so that it's no longer click, and then set the window title to be my one shot app. So here we can change the window title by calling the method set window title. And here, let's look at the code explanation, because we need to able to access the button. Uh, in our the button was click method, we keep reference it on cell. So the text of the button is changed by passing a string to set text method. And if we want to disable a button, we just call the method set enable with false value. And here, let's look at another example. Here we can change the titles of the video, and here we can also count the number of times that the button was clicked. Okay, so here let's look at line number 11. At line number 11, we can see that we initialize number of time click to be 0, right? And then there's the signal click connect, which connect with the button was click. And here the window title is when the window title change, it connect with the method window title change here. And here when the button was clicked, then the variable number of times click is incremented, and the program print out the number of clicks. And then the title is changed, right? uh, Changed by choosing it randomly from this list, which is manager ID and the student ID, and something went wrong. And then the window title here, uh, we check if the window title equal to something went wrong, then the button is set disable by calling the method set disable to be true. So here we have two slot The first one is the button was clicked is which update the number of times that the button is clicked, and it also change the window title. And another slot, the window title change, it will compare the current window title value, and if it's equal to something went wrong, then the button is disabled. And here you can look at the window that uh, when something went wrong title, then the button is no longer clickable. So here, let's look at the code explanation here. We connect window title change signal on human window to a method slot the window title change. And this slot also receive the new window title. First, we set up a list of window title by setting up the list, right? And the list has like name, ID, and the string something went wrong. And then we used Python built-in random.choice method to randomly choose the string from this list. And then the window title change will pick one of the string from this list as the title of the window. And firstly, the window title change signal is not always emitted when setting the window title. The signal only fires if the new title is changed from the previous one, because here we can see that the signal is window title change, right? So if there's no change, then the signal is not emitted. Notice how we are able to chain things together using signal. One thing happen, a button press can trigger many other things to happen in turn. And these subsequent effects do not need to know what caused them, but simply allow a consequence of simple rules, right? If the window title change to one thing happen, right? And uh, then uh, the window title is changed and the button also disabled. And but if a button is pressed, it also uh, can change the window title. When the button is clicked, the method the button was clicked is called, and the window title is changed. The number of click is incremented. And when the window title is changed, the method the window title change is called, and this method will check if the window title is something went wrong. If it is, then the button is disabled. And so far, we have seen example of connecting widget signals to Python methods. And when a signal is fired from the widget, our Python method is called and receive the data. But you don't always need to use a Python function to handle signals. You can also connect Qt widgets directly to one another. Like here, example, we can add a QLine edit widget and a Q label widget inside the window. And here, when the text in the QLine edit is changed, then it can signal to the set text method in the Q label. And now anytime the text change in the Q line edit, then the Q label also receive the text to its set text method. And this the example here. We have QV box layout. QV box layout mean the layout in vertical. So here we have widget as the line edit, right, as the input, and the widget label below the line edit. And here when we um, connect, we say cell dot input dot text change dot connect cell label dot set text. So the signal text change will go to the set text method of the label. And that's why you can see that the label is changed. And here we can also add an app with the quit button and tooltip. And Here we can see that we can set tooltip by calling the set tooltip method, and we can